Hello students, welcome to Power Tutorials. So today we're going to discuss section C of Maths Class 10 CBSE answer key solutions of 30/6/1 set. Okay, so in the previous videos I already covered section A and B videos. So those are, if you want for solutions of those sections, I'll keep those links in the description. You can also check for reference. So there are section A questions which I discussed I think yesterday, and then all the 2018 MCQs, 2 assessment reason questions. And then I have continued section B, which are very short answer questions, that is 2 mark questions, including all the optional part. So till 25 every question are done. So let's start with 25th question, which is from section C. So the first one of section C is they're asking to prove root 5 as irrational. So this is very easy question because this type of question will be coming for every board exam. Okay, so let's solve this. The first step is we have to assume root 5 as rational number. So if it is rational, we can express in terms of p by q. So root 5 is equal to p by q, where q is not equal to 0 and p and q are co-primes. Co-prime in sense they are not having any common factor. So I can say p is equal to q into root 5. Next, squaring on both sides, then I can say it will get p square is equal to 5q square. P square is equal to 5q square. So as I can see, p square is having a factor of 5, then p also have a factor of 5. So I can replace p as some 5 into a. Now I can write 5a whole square is equal to 5q square. 5a square is 25a square is equal to 5q square. So this I can say 5 cancel, then we'll get q square is equal to 5a square. So as q square is having factor of 5, then q also have factor of 5, so which is contradicting our statement. Contradicting our assumption. As p comma q are co-primes. Hence root 5 is not rational, therefore root 5 is irrational. So you have to mention all these points, then I will get full marks of 3 marks. Okay, let's move to the 26th question. Sorry, 26th is done. 27th. Okay, just a minute. So here if you see, this question has 2. Either you can solve A part or B part. So this is a B question here. So if I am in your place, I will definitely choose A part because the A part is the most repeated type of question and you can feel definitely confident and solve these steps. Okay, but still for your convenience I will solve the B part as well. So what is the B part they are asking? They are saying that PQR be 3 distinct prime numbers. Check whether PQR plus Q is a composite number or not. Okay, so for this, the first solution, PQR plus Q, they want to check. So if I take Q as common, I can write this as PR plus 1. So now I have this as one prime factor and this is another factor. It can be composite or prime, doesn't matter, but it has 2 factors. So this number has 2 factors which are q and pr plus 1. So pqr plus q is say composite number. So it is a composite number, it is done. Further, they're also asking to prove, give an example of 3 distinct prime numbers such that this is a composite and this is a prime number. So let's do randomly. What I will do is pqr plus 1. They want as prime and other as composite. So let's try for what are the prime numbers we have: 2, 3, 5, 7, 11, 13 and so on. Okay, so I will take first 3 as first case, 2, 3, 5. So 2 into 3 into 5, what I will get? 2, 3 is a 6, 6, 5 is a 30. 30 plus 1, 31 is a prime number. What about 3, 5, 7? 7, 5 is 35, 35 3 is 105, 105 plus 1 is a composite. So we got both the options. For composite, distinct numbers are 3, 5, 7, whereas the same question they asked for prime number. Distinct numbers are 2, 3 and 5. Okay, this is also easy but still little tricky, we have to think and write, whereas for here this question there is no need to think, we already know what are the steps, you can directly write the steps. So let's go to the next one, 27th question. Find the zeros of the polynomial and hence the polynomial whose each of the zeros is 2 more than the zeros of p of x. Okay, so it is 3x square minus 4x minus 4. 3 4 are 12, factors of 12 2 6. So this is enough because we want minus 4 here. So it is 3x square minus 6x plus 2x minus 4. So if I take 3x common, I will get x minus 2, and here if I take 2 as common, I will get x minus 2. So I will get final step 3x plus 2 into x minus 2. Therefore zeros are 2 comma minus 2 by 3. Okay, so it is not asking only zeros, so this part is done. They are also asking write a polynomial whose each of the zeros is 2 more than the zeros of p of x. If I add 2 more for these zeros, what will happen? So second polynomial, alpha is equal to 2 more than it. So 2 plus 2, which is 4, whereas beta is equal to minus 2 by 3 plus 2. If I take LCM, I will get minus 2 plus 6 by 3, which is 4 by 3. So we have a roots which are zeros which are 4 comma 4 by 3. So the polynomial I can see it is x square minus of alpha plus beta, which is 4 plus 4 by 3 into x plus alpha beta, which is 4 into 4 by 3 is equal to 0. So here I can say it is x square minus 3 4 is 12 plus 4 16x by 3 plus again 16 by 3 is equal to 0. If I take 3 as LCM, I will get 3x square minus 16x plus 16 is equal to 0. This is the new polynomial which is having roots which are 2 greater than the original one. Okay, so we have the zeros of this one, and so if we add 2, we got the second relation which is 4 and 4 by 3, which is 4 plus 4 by 3, 4 into 4 by 3, 4 plus 4 by 4, 12 plus 4, 16, and then else. Okay, let's move to the next one. 27th is one. So this is 28th question. So what is the question they're asking? Check whether the following pair of equations is consistent or not. If consistent, you have to solve graphically. Okay, so graphically here, let's find whether consistent or not first. So the relation is easy. We have to just find a1 by a2, b1 by b2, and c1 by c2. a1 by a2 is 1 by, they have changed this equation to other one, so I'll just change to my convenience, minus 2x plus 3y is equal to minus 12. Okay, always you have to write with respect to x and y terms, not y and x. Okay, now it is 1 by minus 2, 3 by minus 2, sorry, 1 by minus 2, 3 by 3, and c1 by c2 is 6 by minus 12. So it is minus 1 by 2, 3 by 3 is 1, 6 by minus 12 is minus 1 by 2, a1 by 8 is not equal to b1 by 2, so it is, or else these are consistent. Okay, so graphically here I can't able to explain with help of graph sheet, but the how to do I will explain. So if you want, you can just try using this concept which I am explaining here in the graph sheet. You will definitely get the answer. Okay, if you still has doubt using graph sheet, you can just mention the comment section, so that I will prepare another short video where I will use a graph sheet, solve there, and then give you the exact picture. But the how to do it I will explain here. X plus 3y is equal to 6. X plus 3y is equal to 6. The second line is minus 2x plus 3y is equal to minus 12. So how to do means, we have to prepare a box like this. One is x, one is y, and second box, one is x, one is y. Keep x as 0, get the y value. If x is 0, y will be minus 4. If we keep y as 0, get the x value. Y as 0, x will be 6. Same way, x as 0, y will be 2. Y as 0, x plus 0 is equal to 6, x is 6. So we have points. I will use x as 2 centimeters. I will get 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8, 2, 4, 6, minus 2, minus 4, minus 6, x0, y2, x0 and y2 is this point, x6 and y0, x6 and y0 is this point. So these two we have to mark it using scale. So somewhere it will, okay, using scale you just draw it. Okay, so this is the first line, which is x plus 3y is equal to 6. Same way second line, x0, y minus 4, x0, this is 0 comma 0. Okay, x0, y minus 4 is this point, x6 and y0, so this is this one. So these are the second line. So if you notice, these two lines are getting intersected at this point. Okay, I'll just remove this line because it is passing through 6 comma 0. Okay, so these two lines where they are intersecting at this point on x-axis. So that's where the point of intersection, I mean the solution for this question is 6 comma 0. X is 6, y is 0. If you want to cross check and see here, if I keep x as 6, y I am getting as 0. So this is satisfying. Same way here also, if I keep x as 6, y I am getting as 0. So the solution is x comma y is equal to 6 comma 0. Make sure to try this in the graph sheet, not in like a rough sheet. Okay, let's move to the next one. 27th is done. 28th question. the points A, B, C, D are the vertices of a parallelogram ABCD. Then find the values of P and Q and hence check ABCD is rectangle or not. Okay, so this is related to corner geometry chapter. Clearly mentioned it is ABCD is a parallelogram. Okay, A is the point which is having 6, 1 as vertex, B, P, 2, C, 9, 4 and D, 7, Q. Okay, so what is the property for parallelogram is that its diagonals bisect each other. So if I mark this as O, I have to say first point diagonals bisect each other. So O is nothing but the midpoint of AC as well as it is equal to midpoint of BD. Okay, so for AC I am writing first. So O is equal to AC is 6 plus 9 by 2 comma 1 plus 4 by 2 which is 15 by 2 comma 5 by 2. So we have a O point 15 by 2 comma 5 by 2. Now we can find the B and Q. So mid of BD will be P plus 7 by 2 comma 2 plus Q by 2. So this is equal to what we got, 15 by 2 5 by 2. So P plus 7 is equal to 15, so P value is 8. Same way 2 plus Q is equal to 5, so Q value will be 3. So we got P and Q values which are 8 comma 3. Now I can see here this point is Q is how much? Q is 3, so it is 7 comma 3, whereas B value is 8 comma 2. Now we have all the 4 vertices. Now we need to check whether this is a rectangle or not. So for rectangle, what is the condition? Means opposite sides are equal and diagonals are also equal. So we need to find all the 6 sides now. I mean 6 distances. Let's find one by one. So I'll just write all the points first. 6, 1, 8, 2, 9, 4, 7, 3. 6, 1, 8, 2, 9, 4, 7, 3. 9, 4, 7, 3. So this is A, B, C and D. So we have to do it fast because we need to have time for other questions. So 8 minus 2 directly I am doing x1 minus x2 whole square, which is 2 square, plus 2 minus 1 whole square is 1 square, which is root 5. Next BC 9 minus 8 1 square, plus 4 minus 2 2 square, root 5. Okay, CD 7 minus 9 minus 2 whole square is 2 square, 3 minus 4 again 1 square, which is root 5. And last one AD 7 minus 6 1 square, plus 3 minus 1 2 square, which is again root 5. So this is not rectangle, this is square. They're asking to check is it a rectangle or not. Okay, we have to say that it is not a rectangle. Okay, we'll find the diagonals as well. A, B, AC and BD. AC is how much? 9 minus 6 3 square, and 4 minus 3 again 3 square, which is root 18. And BD 7 minus 8 1 square, plus 3 minus 2 again 1 square, which is root 2. So AC is not equal to BD and all the sides are equal. Then it forms rhombus. It is a rhombus, not rectangle. You have to mention the condition as all sides are equal and diagonals are not equal. Okay, let's move to the next question. This is 28th this one. Let's move to 29th. So in 29th we have two questions. Either you can solve this one or this one. Okay, so if I'm in in your position, I'll definitely choose A part again, because this is little tricky, because we need to find sine square and then again square it and then get this relation, whereas here there is no need to do any modifications, but simply algebraic calculation get this relation. Okay, so but still I will solve both. So let's see here, and taking cos theta as common in the numerator, I can say this is 1 minus 2 cos square theta, and if I take sine theta in the denominator, I'll get 1 minus 2 sin square theta. So from the first identity, which is cos square theta plus sin square theta is equal to 1, I can say cos theta by sin theta is already cot theta into 1 minus 2 into sin cos square theta. I'll write it as 1 minus sin square theta by 1 minus 2 sin square theta. Okay, so in the next step, I will write this as cot theta into 1 minus 2 plus 2 sin square theta by 1 minus 2 sin square theta. What is 1 minus 2? It is minus 1. So this becomes cot theta into minus 1 plus 2 sin square theta by 1 minus 2 sin square theta. So if you see here, both are same, but simply minus you have to multiply. So this becomes minus 1. We also have one term here, plus cot theta plus cot theta plus cot theta plus cot theta. So cot theta into minus 1 is minus cot theta. So minus cot theta plus cot theta, which is 0. Hence cos theta minus 2 cos cube theta by sin theta minus 2 sin cube theta plus cot theta is equal to 0. Okay, let's solve B part now. They're saying sin theta plus cos theta equal to x. Prove that this relation. Okay, so first what we will do is square on both sides. If we do squaring on both sides, I will get sin theta plus cos theta whole square is equal to x square. Sin theta plus cos theta is sin square theta plus cos square theta plus 2 sin theta cos theta is equal to x square. Sin square theta cos square theta already know, which is 1. So 1 plus 2 sin theta cos theta is equal to x square, or you can say sin theta cos theta is equal to x square minus 1 by 2. So keep it as 1. Now next point, let's use the identity here. Sin square theta plus cos square theta is equal to 1. So let's square this on both sides. If I square this on both sides, what will happen? I will get again sin power 4 theta plus 2 sin square theta cos square theta plus cos power 4 theta is equal to 1. So sin power 4 theta plus cos power 4 theta is equal to 1 minus 2 sin square theta cos square theta. So what is sin theta cos theta? We got in the first relation, which is x square minus 1 by 2. So I'll just replace the same point here. This I can say it is 1 minus 2 into x square minus 1 by 2 whole square. So this I can also write 2 into x square minus 1 whole square by 4, 2 ones, 2 twos. So from this last point step I'm writing here itself, which is if I take LCM, I will get x minus x square minus 1 whole square by 2. Okay, let's move to the next one. This is which number? 29th is done. So this is 30th question. Okay, this is the last question for section B. Sorry, section C. I'm sorry for the I got cold, so there is some disturbance, but still, let's continue with the question. In the adjoining figure, TP, TQ are the tangents. Okay, OPQ is 15 degrees. PTQ, this whole angle is Q. Okay, when you find the angle of sine 2 theta. So I think similar question is already there in the exercise questions as well. So if you have followed all the exercise questions of triangles and circles chapter, you will definitely solve this question. Okay, let's solve this. So what I will say, the first point is I will join OQ. Join OQ, which is radius to circle. Okay, consider triangle OPQ. If you consider this triangle, OP is equal to OQ, so angle OPQ should be equal to angle OQP, so which is 15 degrees. So this angle is 15. So if you consider both the triangles, I mean full angles of triangle, then angle POQ plus 15 should be equal to 180 degrees. So angle POQ is equal to 180 minus 30, which is 150 degrees. So I got an angle which is, this angle is 150. Okay, now consider the quadrilateral OPQT. Consider quadrilateral OPQT, then I'll get 4 angles: OPT, PTQ, OPT plus PTQ plus TQO, TQO plus angle QOP. QOP, all summation of all angles of quadrilateral is 360 degrees. OPT is tangent angle, which is 90 plus TPQ. PTQ is the one which you need to find. Let's write as theta. TQO is again 90 plus QOP we just found, which is 150 degrees, is equal to 360. So it is theta plus 180 plus 150 is 330 degrees is equal to 360. So theta is equal to, we got the angle 30 degrees. Keep it as box. This also carries half mark. Let's go to the last step. Sine 2 theta, which is sine 2 into 30, which is sine 60. Sine 60 is root 3 by 2 is the final answer. Okay, so in this way all the questions of section C are done, and in the next video you can find the solution of section D. Mostly I will solve it and keep it uploaded tomorrow by 6 p.m. or else by 8 p.m. Okay, so make sure to like this video if you like the content. Also please do subscribe and enable notification for further videos. Thank you.